Okay, next video. So we're up to rule 3. The integral from a to b of k times f of x dx is k times the integral from a to b of f of x dx, k a constant. Numerical coefficients can be factored out. Number 4, the integral from a to b of f of x plus or minus g of x dx is the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. Integrals, definite integrals, may be split up by addition or subtraction. These last two, if you think back to when we did indefinite integrals, the guys without limits of integration. And remember, indefinite integrals equal functions, definite integrals equal numbers. These two rules were also rules in definite integrals, indefinite integrals, excuse me. They were also rules in indefinite integrals, that you could factor out coefficients and you could split up indefinite integrals by adding and subtracting. So there seems to be, the notation, there seems to be a lot of similarity in the notation between definite and indefinite integrals. Now there seems to be similarity in some of the rules between indefinite and definite integrals. And we are moving to trying to connect those two things. 5, the integral from a to c of f of x dx equals the integral from a to b of f of x dx plus the integral from b to c of f of x dx. And so you need to note what's going on here. That the upper limit and the lower limit, the upper limit of the first definite integral and the lower limit of the second definite integral are the same. And that's for any value of b. But if we think about it in terms of area, this too makes sense. That is, say this is our picture here. Instead of b over here, this is c. And so this is sort of saying that the area from, say, a to 0 plus the area from 0 to here, pretend that said a c. So a to 0 plus the area from 0 to c, pretend that says c, that had to be the whole original area. So it makes sense in terms of area. Now it's much more generalized than that. It doesn't have to be an area issue. But it does make sense that the area from here to here plus the area from here to here has to be the total area, if we think about it in terms of area. But definite integrals do not have to be area. So it is much more general than that. But what you want to remember is the upper limit and the lower, if the upper limit and lower limit are the same, you can kind of smush those guys together. There's a completely non-mathematical word, smush. 6, if f of x is greater than or equal to 0 on a to b, then the area bound by y equal f of x and the x-axis on the interval a to b is given by area equals the integral from a to b of f of x dx. So if my function is positive, and we've already seen this in action, if my function is positive, that area equals the integral from a to b of f of dx, f of x dx. That when your function is positive, the definite integral will give you the area. Now the flip side, if f of x is less than or equal to 0 on a to b, then the area bound by y equal f of x and the x-axis on the interval a to b is given by area equals the opposite of the integral from a to b of f of x dx. So if we are below the x-axis, then that area equals the opposite of the definite interval. If we didn't have the opposite, since it's below the x-axis, all those heights in air quotes, all those heights, all those f of x sub k's, all those values would be negative. And so the Riemann sum would give me a negative number because each height would be negative. Well, if I want to call it area, areas are only positive, I need to then take the opposite of that. So if you're below the x-axis, the area is given by the opposite of the definite interval. So now we're going to use these facts, rules. Suppose that f and h are integrable, and that the integral from 1 to 13 of f of x dx equals 6. The integral from 5 to 13 of f of x dx equals -5. and the integral from 5 to 13 of h of x dx equals 4. Find each of the following. Showing every detail I can think to show. First of all, I can split up definite integrals by subtraction. And I can factor out coefficients. And then they've given me each of the values I need from here on out. Go out a little bit. They told me that f of x from 5 to 13 was negative 5. So that's going to be 3 times negative 5 minus 5 times, and then they told me 5 to 13 of h of x was 4. So I'm going to have 5 times negative 4, and what? That's all negative 35. Okay, next guy. Next guy's going to be a little easier. (13 to 1 of f of x. I was given 1 to 13. Well, that's easy enough to fix. I can interchange the limits as long as I negate the integral. So I have 1 to 13, so change it to 1 to 13 as long as I negate the integral. And so that's going to give me negative 6. Okay, the next one. 6 to 6. Upper and lower limits are the same, so this is automatically 0. Upper, lower limits equal. Some textbooks will try to do something really, try to give you a really scary problem. And some textbooks might do this. They might do 3 to 3 of the square root of x squared cosine, let's say x to the 6th times sine x dx. And you're looking at it, and they're purposely trying to scare the hell out of you. I mean, look at that horrible, horrible integrand. X squared cosine x to the 6th sine x dx. Oh my God, all that trigonometry. I'll never be able to do it. 3 to 3. 0. So if you're doing your homework, and especially in this section where we haven't done too much with it yet, and they give you this horrible, horrible looking problem, look at those limits of integration. Okay, next one. 1 to 5. I'm not given 1 to 5 up there for f of x. I'm given 1 to 13 and 5 to 13. I need to figure out 1 to 5. Well, we could do this. I could start with the biggest interval I was given, 1 to 13. And then one of my rules said you could break these guys up pretty much any way you wanted, as long as the upper limit of the first integral matched the lower limit of the second integral. And so I took the big interval they gave me, 1 to 13, and I split it up at 5 because they asked me 1 to 5. So I chose, because you can choose any number you want, I chose to split it up at 5. So 1 to 5 of f of x dx plus 5 to 13 of f of x dx. That's one of our properties. And so now we can just fill in. 1 to 3 of f of x dx was 6. 5 to 13 of f of x dx was negative 5. So I'm going to have 13 equals the integral from 1 to 5 of f of x dx minus 6. Again, the interval from 5 to 13 was not 6. It was minus 6. It was 5. All right, so 5 to 13 was minus 5. 5 to 13 minus 5. And now just solve for this guy. Add the 5 to the other side. And so we get not 8, let's add correctly. 18 equals the integral from 1 to 5 of f of x dx. Or if you don't like it in that order, 1 to 5 of f of x dx equals 18. So this one a little trickier in that you had to realize you could take the big interval that we were told about and split it up into 2 smaller intervals, choosing to split it up at 5 since that's what they were interested in. Then the last one, 5 to 13 of f of u plus h of u du. The point here is what I call the variable I choose to use. It doesn't matter. You know, if I go back to my little picture here, how far back do I have to go to a little picture here? I would have gotten the same answer whether I called this x1, x2, x3, or if I called it u1, u2, u3. It doesn't matter what letter I choose to label my horizontal axes. It's just convention that we've used the letter x. If this had been used down here, it wouldn't have changed any of the calculations. So the variable you choose to use does not matter. This is going to be the same thing as 5 to 13 of f of x plus h of x dx. And so 5 to 13 of f of x dx plus 5 to 13 of h of x dx. And then up at the top, which you can't see anymore, but we were told that 5 to 13 of f of x dx was negative 5. And we were told that 5 to 13 of h of x dx was 4. And so our answer is negative 1. But the point here, the name of the variable just doesn't matter. Okay, next problem. Graph the integrand and use areas to evaluate the integral. Okay, so let's graph this guy first. And I don't care how you graph this. You could graph it on your graphing calculator. Whatever you want to do is fine. But let's graph y equals 6 minus the absolute value square root of x. And I'm just going to do an old-fashioned t-chart. So -2, -1, 0, 1, 2. Just going to do it old-fashioned way. And so if I plug -2 in there, that's going to give me 4. If I plug -1 in there, that's going to give me 5, 6, 5, 4. And so graphing this, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, -2, 4, right there, -5, 1 there, 0, 6, 1, 5, 2, 4. And so the graph looks something like that. And it says use the graph and use areas to evaluate the integral. Since this is above the x-axis, so this integral equals the area. Specifically, if I drop this down, it's going to equal that area. And so there's the logic, and we're going to end this video and actually find that area on the next video.